Hi, in today's lesson, I'm going to use a PhET simulator to illustrate how nuclear fission occurs. You notice the kind of atom we start with says U-235. This is a certain kind of uranium atom that has a mass number of 235. That is, it's got 92 protons as uranium and 143 neutrons. That combination of protons and neutrons will stay together fairly well because the strong force is able to hold all those particles together. In nuclear fission, we actually make the atom split nearly in half. And in order to do that, we have to make the atom become much more unstable. So, on the left is a gun that fires a neutron. Neutrons are what start the entire process. So, when a neutron hits the uranium-235 atom, the uranium atom turns into uranium-236. You wouldn't think one neutron would make that much of a difference, but it does. As it turns out, the extra neutron makes the atom about as stable as a Kardashian marriage. Doesn't hold together very well at all. And eventually, the atom will become so unstable that it will break apart into two different halves. You notice we have two large daughter nuclei, the medium-sized nuclei that you get with nuclear fission. You also have a couple of neutrons. So these over here are all neutrons. Those neutrons can go on to make other atoms split apart. The other thing you'll notice is that there's that yellow circle which represents all the energy given off. Nuclear fission releases energy in the form of heat. So, this whole process happens very quickly. Let me go ahead and do it one more time, only this time at full speed. So, we've got the uranium nucleus. The uranium absorbs a neutron, becomes unstable, and it splits apart. So, do it one more time, maybe a little bit more slowly here. Right? We release a neutron. The uranium absorbs the neutron, becomes uranium-236. The uranium-236 splits apart, and it releases two daughter nuclei and a couple of free neutrons all by themselves, with those other neutrons being able to split other atoms. And finally, the whole process of nuclear fission releases a lot of thermal energy.